So this is called a line graph here. And on the x-axis is the age of a person. And on the y-axis is the vocabulary size. So a 5-year-old is expected to have somewhere between 5,000 and 10,000 word vocabulary. That's what that dot means, because it's that 5 on the x-axis, and it's like maybe 7 or 6 on the y-axis. So for part A, we just did that, the 5-year-old's vocabulary, it's somewhere between 5,000 and 10,000. So I'll guess a halfway point is 7,000. Okay. The other option here is 9,000. That's somewhere between 5 and 10,000, but 9,000 would be closer to the $10,000 line than the 10,000 vocabulary line. So 7,000 is the better estimate there. 50-year-old vocabulary, we go over to 50 for years. So this is where 50 is for years. And then we match it up with the dot that corresponds with 50 years right here. So that's a little bit less than 35,000 for the y-axis. So a little bit less than 35,000. A 50-year-old's vocabulary is about how many words more than a 5-year-old's vocabulary? So we can just find the difference between these two, right? 33,000 subtracted by 7,000. Let's see. So 26,000. And D, the number of words in a 50-year-old's vocabulary is about how many times greater. So if you're trying to find out how many times greater something is to something else, you should be able to multiply it by that number, and it turns into the other number. So what would we multiply 7,000 to make it equal 33,000? So that's a division problem. Okay, take 33,000, the bigger one, and divide by the smaller one. That's 4.714 times greater, but they say round to the nearest hundredth, so that's the second decimal place. This one rounds down to 4.71.